What's going on, guys? My name is Johnny Bandon, and I'm your CCNA instructor for this video series. In this video, we're going to go over subnetting, why we subnet. I'm going to go over how I subnet and the little story of how I learned how to subnet. We're going to do subnetting based on host. And this first video is just going to be subnetting for class C host, so working in that fourth octet. And then the next two videos will go into the third and second octet, subnetting class A and class B IP addresses. So again, first we're going to go over why we subnet. And there could be a lot of reasons why we need to subnet. So let's go over that why. So first off, in an enterprise environment, before getting into ISP allocating us IP addresses, we got to go over the point of subnetting within our enterprise. Because our private IP addresses are so big of ranges that we can have internally, what would be the point of subnetting this down to smaller networks when we could just do a /24 for all of our logical segmentation? Well, the truth is that is something we can do. Instead of subnetting this /24 to meet user needs, we could just make a bunch of /24s on our internal networks. Now, the reason we might not want to do this is because architecturally, we may be wasting private IPs, especially if we grow into a huge campus network, right? So now let's get into why we would subnet in this corporate office. So let's say we get assigned a /24, right? And office A here has 40 users. This office, we'll call it office B, has 60 users. This big headquarters has 100 users. And we need to segment or separate or subnet these three host requirements from this /24. From this one network, we are going to have to create subnetworks. That is why we do subnetting. And we use this starting value or network address and subnet mask to break down our allocated space into smaller subnets. So let's dive right into it. And before we go straight into subnetting, let's go over a few key things that you may miss in our IP addressing videos. So, first things first. This network, .0, that is a what? Network address. Net ID. /24, if we write that into 255.255.255.0, that's our subnet mask. If we convert that to binary, this is what it's going to look like. 24 network bits, right? Ones are the network bits that determine the network portion of our IP addresses of our network, and zeros are the host bits. Okay. What else do we need to go over? The last IP address in this network, .255, is going to be a what? Broadcast. These two IP addresses, the net ID and the broadcast, cannot be assigned to any host or users in our network. Okay, so again, just going over some of the basics here. What a net ID is or broadcast IP address is. What a subnet mask looks like. What the ones are and what the zeros are. All this is going to be important when we dive right into this subnetting. Let's just go ahead and get our feet wet, right? So this is the first network we're going to work with. So let's take note of something, guys. We have our 4 offices here with their own LANs, their own networks, right? Their own broadcast domains, a term that we'll learn later on in our section going over layer 2 and stuff like that, our own broadcast domains. their own networks, have their own host requirements. But let's pretend we have routers here, right? That connection between ISP and us is also a network. It's important to take note that we may have to subnet that way too, depending on our relationship with the ISP, right? Well, typically they're just going to assign you IP address, real world. But for the sake of the test, this is something we need to know. This is also a network right here. The connection between your customer edge router and that ISP provider edge router. Okay, so now we're going to have to break down this starting network into how many different subnets? 1, 2, 3, 4, 5, 6, 7, 8. Now let's go ahead and do it. So a couple rules first to go over, right? We always want to subnet based off the highest host requirements. So in this case, we all have the same host requirements for our spokes. But let's say this was 50. This was 14, 32, and 6. We would first subnet for this host requirement, then this one, third, and then last. We go from highest host requirement to lowest when subnetting. And now let's go over our 3 rules of subnetting. And again, a little history of this, how I learned this. I was in the Army, a special operations communicator veteran. And in my first unit, my boss, or what we call leaders or NCOs in the Army, taught me subnetting exactly like this. He said he got it from a trainer on CBT Nuggets a long time ago, and this is how he's always taught anyone to subnet. And this has always stuck with me, and out of all the boot camps and training I've gone to, this has always been the easiest for me to subnet. I've had other trainers try to show me how to subnet in my early days their way, and this way just always stuck with me. Now this is how I know it. So for my CCNA course, 8 years, 9 years later doing networking, I decided to make my own CCNA course. Well, how do I teach subnetting? Well, this is the only way I know how to do it. So if you've seen this in other videos, great. Maybe that's the source material. Because other people have told me, hey, I know I've watched videos and they submitted the same way when I do my in-person classes. So again, not trying to steal anyone's formula. Again, it's not really anyone's secret sauce, right? Everyone learns subnetting from somebody, right? But this is how we do it. And this is how my company and how I'm going to teach it. So first step, we're going to convert the number of hosts to binary. Second step, we're going to write out our subnet mask in binary. We're going to reserve the host bits, and then we're going to find our network increment, which is really just our range, right? And then we're going to, once we find that increment, we generate our network ranges, okay? So let's break this down. And I'm going to do this at a snail's pace. And then this next one right here, I'm going to also do it at a rather slow pace. And then our next videos for the Class B and Class C, I'm going to go a little bit faster. Okay, so let's do it. Our first step, convert the number of hosts to binary. So we're going to subnet for the corporate office here. This is our starting point. We need a subnet from this network. We have a 28 host requirement. So we're going to convert the number 28 to binary. And we're going to see how many bits it takes, okay? So how many bits does it take to get to the number 28? To figure this out, we're going to write out our binary conversion chart. All right. And now we're going to convert this number 28 to binary. Let's do it. Is 28 greater than or equal to 128? No, it is not, right? Greater than, I'll write this up here, or equal. Now, I haven't been to math class in a while, but I think this is the symbol. Not sure. Just forget I said that. Is 28 greater than or equal to 64? No, it is not. Is 28 greater than or equal to 32? No. Is 28 greater than or equal to 16? Yes. 16 does go into the number 28. And if we subtract, we get the number 12. 8 does go into 12, or 12 is greater than or equal to. That's a bit. 4, that's an on bit. Then the rest are zeros. Okay. Now looking at our binary conversion chart, we have 8 bits up here. But how many bits does it take to get to the number 28? 1, 2, 3, 4, 5. Now this may be a little confusing. You're like, whoa, wouldn't we just count the on bits? And no, because if I just throw up 3 ones without the trailing zeros, that would equal 1, 2, and 4. We need those trailing zeros to line up with our conversion chart. Let me erase some of this. To get that full number 28, right? Because again, if we just left the ones there, say, it takes 3 bits, 3 1 bits. Well, if you line that up, that would only equal 1 plus 2, 3 plus 4, 7. We need those trailing zeros. We need those trailing zeros so we can get our total number 28. Because when you line this up to the conversion chart, all 5 bits, 16 plus 8, 24 plus 4, 28. So how many bits does it take? 5 bits. All right, awesome. Now, the next step, we're going to write out our subnet mask. We're also going to go ahead and we're going to convert it to binary. And we're starting from our original subnet mask, okay, guys? The original, the OG. Every time we subnet, when we try to find our new subnet mask, we start from the original when we do this step. Then the rest are zeros. So now, reserve the bits in the mask, our original mask. So what does that mean? That means from right to left, we're going to make sure that we have 5 host bits. What are our host bits, guys? Our zeros. So from right to left, we're going to make sure that we have 5 host bits. So 1, 2, 3, 4, 5. And then if I draw a line here, from right to left, we need 5 host bits. Well, what are we going to do with the rest of those zeros? We're going to flip those to network bits, okay? And now that we flip them to network bits, we have found our new subnet mask, guys. So our original one is 255.255.0/24. Our new subnet mask is going to be a /24, 25, 26, 27. So what is that? 255.255. What? Well, if we take these 3 network bits, line them up to the conversion chart, and add up their values, 128 plus 64 is 192. I'll write that out. 192 plus 32, 224. Our new subnet mask is .224/27. Sweet, we did it, right? Okay, now we have to find our increment. So what does it mean? Find our increment. It means we're going to look at that last network bit. Let me change my pen color again. This third one, right? We're going to take that bit. We're going to line it up to our conversion chart, see its value, 32, and that's going to be our network range. Our network range is 32 for our first host requirement in subnet. So now let's write this out. So what did we find out? We found our new subnet mask. And now we need to subnet it from our original. So our original network is 192.168.10.0. And our network range is 32. So if we add 32 to 0, what do we get? We're going to get 192.168.10.31. All right, guys. So we have found our first subnet. And that's a /27. So we found out how many host bits, or what our host requirement is, and how many bits it took for us to say, hey, this subnet can fit your host requirements. If you have 5 host bits in your subnet mask, you have a total of 32 addresses available, right? Now, how many usable do we have available? Well, remember, our network address and our broadcast address cannot be used. So this first one right here is our net ID. This last IP address here, the end of our range. And remember, 0 counts as a number. So 0 plus 32 in networking and subnetting is 31. That's our broadcast address. Our usable IPs are .1 through .30. Usable. All right. So we have just subnetted for our Trepa Tech corporate office. Our new subnet is 192.168.10.0/27. Our net ID is .0. Our broadcast address is .31. And .1 through .30 is our usable, with .1 most likely going to be our default gateway. Okay. So now we have decided and said, hey, from that original network, we have taken this chunk, .0 to .32, and assigned it to this corporate office. So now these IP addresses, .0 to .31, can no longer be used unless it's in this office. So now what do we have left? We have IP addresses .32 through .255 left. And I'm going to write this out. Okay. Now we need to subnet for our offices down here. So let's subnet for this one. I know what you're saying. Well, this is pretty obvious. It's just going to be the same thing. And you're right. But when we're so new, we got to do this a couple times. Even if it's the same host requirements, we got to do this repetition. And I'm going to go just the slightest bit faster. Okay, guys? So let me try to get all this off, because I didn't have to delete the binary conversion chart. And let's do this all again. So for Office A, we have 28 hosts. So we're going to convert the number 28 into binary. So we come up here, we make our binary conversion chart. And we see if 28 is greater than or equal to all these numbers. So no, no, no. Yes. And now, guys, do I have to finish the rest? Once I get that first on bit, do I know how many bits it's going to take? Yes, I do. Because once I have that first on bit, I know that the rest of these are going to have to be ones or zeros. I'm going to need those bits to equal the number 28. So if we were to finish this out, we could, no harm, and we could count 1, 2, 3, 4, 5. But at this first one bit, this on bit, we already know. 1, 2, 3, 4, 5. 5 bits. Next step, first thing we're going to do, go to our original mask, okay? We're going to convert that to binary. And then we're going to reserve our host bits. How many bits do we need to get the number 28? We need 5. So from right to left, we need to reserve 5 host bits and say, hey, no matter what, we need these 5 host bits right to left. There's our cutoff, right? 1, 2, 3, 4, 5. And then we're going to flip the rest to network bits. So now we have a /27. And if we take these network bits, put them up against our binary conversion chart, add those up, 128 plus 64 plus 32 is .224. Our new subnet mask is 255.255.254/27. And now we need to find our network range. We do that by taking this last network bit here, putting it up against our binary conversion chart, finding the value, 32, and using that to generate our network range. So now we come down here. We see that the Trepa Tech corporate office was already using these 32 addresses here. They already have this section of our network. They have that subnet. So we're going to add our network range or our increment, which is 32, to 32, which is going to equal .63, okay? I know. Networking math is weird. And that's a /27. .32 is our network ID. .33 is going to be our first usable and default gateway. .62 is going to be our last usable. And .63 is our broadcast address. All right, guys. And that's it. And if we start this over again, and I'm going to erase this completely. I'm going to write back up here what we already know and just do it like this. If we go to, we already have subnets for these 2 offices or host requirements. I'm going to finish this and I'm going to go a little faster, okay? So 28, how many bits does it take? I'm going to go faster by still trying to write legibly though. 28 doesn't go into 128, 64, 32. It does go into 16. There's my first bit. So now I know it's going to take 1, 2, 3, 4, 5 bits to get the number 28. I'm going to write out my subnet mask. I'm going to put it in binary as well. My original subnet mask is a /24. So 24 network bits, which are my ones, right? Which leaves 8 host bits to be subnetted from. I'm going to reserve 5 host bits right to left, and then flip the rest to network bits because we only need 5 bits to have 28 host get IP addresses. I'm going to add these ones up in our binary conversion chart. They equal 224 because we're going to take these values up here. Our new subnet mask is 255.255.224 with a /27 because now we have 27 network bits, right, in our mask, our subnet mask. We're going to find our increment, which is this last guy right there. Its value in the binary conversion chart is 32. So starting from our new network range, because 0 to 31 is taken here, 32 through 63 is taken here, right? I can just actually write these out here. We start at .64 plus 32 is what? This is going to be that weird networking math again, right? So let's see here. It's going to be .95. So now this office B has .64 through .95. The next office has the same exact host requirements. So 96 plus 32 is what? That's going to be 127, right? And essentially what I'm doing here in my head, I guess I should explain it, is I'm adding 64 and 32 like you do regularly, which is equals 96, and then minusing 1, okay? Because again, remember, 0 counts as a number. So we're always going to be kind of like at a -1 when we're doing our addition for subnetting. Awesome. So we found our network ranges for all of our offices. Now let me erase the rest of this. And we're going to do it one more time for our 2 host requirements. Okay. And then we're just going to do that 2 host requirement one time, because once we figure out the network range and the subnet mask for this requirement right here, we know it for all of them. So let's do it. Convert the number 2 to binary. Binary conversion chart. I'm going to skip all these because I know 2 is not greater than or equal to all these. But it is to the number 2. It takes 2 bits to reserve enough IP addresses for 2 hosts. We're going to start at our original subnet mask again, guys. We are going to write out the binary. I know it's so tedious, but when we're fresh, we're rookies learning this. It is important that we understand the entire concepts and the binary and the conversions, right? From right to left, we need to reserve 2 host bits. The rest flip on to network. And now if we line those network bits up and we do some crazy addition, 128 plus 64 plus 32 plus 16 plus 8 plus 4, that's going to equal 252. Our new subnet mask is 255.255.252/30. So we now have 25, 26, 27, 28, 29, 30 network bits. We're going to take that last network bit in our mask, find the value on our binary conversion chart, 4, and that's going to be our new network range. So 128 plus 4 is .131, and boom, there's our new network range, and that's a /30. So now if we were to finish this chart out, this is what it would look like. And we have just successfully subnetted this network. My suggestion for you guys, we're done with this video, our part 1 of subnetting. Go back and rewatch it. Maybe play me at 0.75 speed. If you follow these steps each time, you will subnet successfully. And I am going to suggest that online there are subnet calculators. There's applications in the App Store that let you practice subnetting. This is a very important skill for the CCNA test. A lot of my students that have come back to me, of course, would never tell me what was on the exam because that's against the Cisco NDA, but they said subnetting was very important to understand. It's important that you can look at a CIDR notation and know 4 hosts or 4 IPs total. It's important. So in our next video, we're going to go over, I said I was going to get to this video, but it's way too long now. We're going to go over a class A again. Then we're going to hit a class B and a class C, okay?